morning, everyone. I'm SungHyun CHOI from Samsung Electronics. I'm really excited to give an opening speech today at 6G Global event. Actually, I am currently heading the standardization and research of 5G advanced, 6G, and IoT connectivity at Samsung Research. At the same time, actually, I'm heading the advanced R&D at Samsung Networks. So today, I'll be sharing the current standardization direction and also technical trends towards 6G today. So I will briefly touch standardization process and then to be followed by 6G technical trends. So we all know that 3G was introduced under the name of IMT 2000. And then 4G was introduced under the name of IMT Advanced. And finally, 5G was introduced under the name of IMT 2020. And currently, we are living in the era of 5G. And now, we are also working on 6G, which will be part of our daily lives in the 2030s. And because we all know that actually, roughly every 10 years, a new generation of mobile communication technology has been introduced. As you might know, ITUR has been working on 6G framework. And as of June this year, ITUR finalized drafting IMT 2030, or 6G framework recommendation. So as I just mentioned, 6G will be officially called IMT 2030, right? And as part of that framework recommendation, this document covers some trends in terms of users, applications, and technology trends, and also spectrum implication and evolutionary direction of IMT. And if you take a look at this document, basically this document shows a couple of diagrams which are shown in this slide. So the left-hand side, we see 6 usage scenarios of IMT 2030. So that includes 3 usage scenarios which are advancement or an enhancement of 3 usage scenarios of IMT 2020, that is 5G. And then on top of that, 3 new usage scenarios were newly defined. Those include basically integrated sensing and communication, AI and communication, and finally, ubiquitous connectivity, right? So along with that, basically, this usage scenario should be kind of supported along with sustainability and so on, right? And then if you take a look at the right-hand side, there are basically 15 capabilities to support these usage scenarios. At the bottom, we see a number of green-colored capabilities, which are, again, enhancement of the capabilities defined in 5G. And then we see 6 new capabilities which are kind of newly defined as part of IMT 2030 or 6G. I'd like you to take a look at this diagram more carefully later on, and then I will move to the next slide. So along with, or as part of this 6G framework, basically ITUR defined the timeline for 6G standardization. So that means the goal is basically to finalize the standardization of 6G in 2030 so that 6G can be actually part of our lives in the 2030s, right? So if you take a look at the upper part of the kind of roadmap, basically recommendation will happen around 2030. And before then, there should be basically proposal and evaluation process. And also beginning next year, ITUR will work on technical requirement and so on. So as you might be familiar, when ITUR defined this kind of timeline and goal, 3GPP has been defining technical specification to meet ITUR requirement and timeline and so on. So if you take a look at the bottom line, this is a timeline of 3GPP standardization, which is proposed by Samsung. So roughly speaking, or actually, especially if you take a look at the green colored timeline, that's a timeline of RAN working groups, RAN 1, 2, and so on. So we are currently working on 5G Advanced as part of Release 18. And then beginning sometime next year, we'll start working on Release 19, again, which will be part of 5G Advanced. And then around 25 and so on, we will actually start working on 6G, right? And then the goal is to finalize the very first release of 6G, which is Release 21, by the end of 28. And then Release 22 will continue. But as I said, basically, the very first release of 6G will be 21. And then based on that, we hope that ITUR will standardize 6G or IMT 2030. So actually, in order to make this happen, we need to collaborate all together. So hope that we can make 6G, with the goal defined by ITUR properly in a timely manner. So for the rest of my talk, I will talk about some technical trends of 6G. But before talking about technology, I would like to briefly talk about spectrum issue. Because we are talking about mobile communication, and inherently, we need spectrum to do mobile communication, right? And we all know that we have been exploring lower band under 1 gigahertz. And also, as part of 4G and 5G, we have been exploring FR1 and FR2. That includes basically lower mid-band below 7 gigahertz, and also millimeter wave band, or FR2, above 24 gigahertz. And as part of 6G, I think we need to identify some new spectrum, and also we should try to reform the existing spectrum for 6G purpose. So actually, if you take a look at this diagram, we have upper mid-band from 7 to 24 gigahertz, which we will probably call FR3. So FR3 could be a new spectrum which we can explore for 6G purpose. And also, again, as I said, as part of 6G, we need to better utilize FR1 and possibly FR2 as well. And along with that, basically, we need to develop some technologies like carrier aggregation and dual and multi-connectivity and so on too. And also, when we introduce 6G, probably we might need to define some technologies like spectrum sharing between 5G and 6G too. And I believe actually interworking with non-3GPP or non-mobile communication should be part of our consideration too. So this spectrum issue is very local in many cases, so different spectrum used for different countries. But at the same time, ITUR will be the place where we can discuss to identify some global spectrum for 6G purpose too. And again, for that purpose, all the stakeholders across multiple countries and companies should work together. I hope that this will really happen. And then let's take a look at new attributes of 6G. Well, if you take a look at the left-hand side, I show basically the spider diagram comparing 5G and 6G. We all know that basically from 4G to 5G, there has been major upgrade in terms of major KPIs. That includes peak rate and also latency. We believe that from 5G to 6G, of course, we'll try to improve these major KPIs, but the change or upgrade might be rather moderate compared with the kind of big jump from 4G to 5G. Instead, I think 6G should be defined so that we can better satisfy our customers in terms of end users and also operators and so on. And then towards that end, we would like to propose 4 new attributes of 6G. These new attributes include AI nativeness and sustainable network and ubiquitous coverage, and finally, quantum safe and high resiliency. Basically, these 4 new attributes will be defined so that they can be future-proof, and also that they can provide sustainable user experiences. So again, if you take a look at these 4 new attributes a bit more, basically AI native and sustainable communication will optimize network and user equipment jointly. So in this slide, I show for all 4 new attributes, there are multiple enabling technologies and underlying attributes and so on. And then in the following slide set, I will briefly talk about these 4 new attributes and underlying technologies or enabling technologies a bit more in detail. So I believe we have been hearing that 6G will be AI native, right? I think it can be understood in many different ways. Basically, AI will enable 6G more efficient and stronger and so on. And also 6G should be defined so that many different types of AI applications and services are better provided and so on too. So if you take a look at the current 5G AI applications, we are trying to utilize AI for many different purposes, including network planning, prediction detection, self-healing, and network management, and finally, performance improvement. And 6G AI, again, 6G will be AI native, and also comprehensive and end-to-end, right? So as of 5G, basically we are using AI for different purposes, but in a fragmented manner, right? Either in UE or in RAN or core in a separate manner. But towards 6G, again, as I said, AI should be used for the optimization or performance enhancement in an end-to-end manner. So as shown in the figure, from UE to application server or cloud. As you might know, there have been a lot of approaches to enhance 5G or 4G network performance using AI. And also today, 3GPP is looking at the possibility of applying AI in different layers, even inside, even at the physical layer today, right? So if I kind of briefly mention some of them here, AI can be apparently utilized to fulfill some missing information. I assume that many of you heard about, I think, super resolution, which is highly utilized in image, kind of upscaling today, right? And this kind of similar technology can be utilized for communication purpose. So upscaling some kind of channel information, right? And also prediction of different cells, especially secondary cell channel information prediction and so on, right? And then AI can be utilized for beamforming optimization and multi-user scheduling, link adaptation, power saving. And apparently, along with ORAN's non-real-time rig, AI for automation can be used in a form of RFs. And we are trying to utilize this kind of RFs for different purposes, like network analytics and network parameter optimization and so on. So I just briefly mentioned different kind of AI applications, but I believe, as of today, we are having better understanding about the usage of AI in our future communication technology. There's always some trade-off, right? Performance enhancement and complexity and so on. But basically what I believe is, given that AI technology itself is improving very fast, and also the supporting hardware technologies being also developed fast, I believe in the era of 6G, I believe that our vision to make 6G AI native and also making AI kind of enhance different parts of 6G communication across end-to-end, I think that will happen. But I think we need to make more efforts to achieve that. So the second one is sustainable network. So sustainability is very important keyword today in different areas, right? But in here, I will share some of the ideas, especially in the context of energy saving, energy efficiency, and so on. So the first one is network and UE power saving with RF innovation. So we all know that, especially in terms of transmission, power amplifier consumes most energy, right? So making power amplifier energy efficient can be very important area we have to take a look at. And as you might know, basically power amp utilize basically supply voltage, right? And then today, most power amps use constant supply voltage. So that even if TX output is very low, still the power amp ends up consuming a lot of energy. So the better way is to adjust supply voltage depending on output power. So from constant voltage to changing supply voltage by tracking average output power. So that's the next step. And finally, if we can adjust supply voltage in a very fine-grained manner according to following the output power, then as shown in the slide, we can achieve very high power amp efficiency. So actually working on this envelope tracking kind of technology is very important, and I believe many of you are looking at this approach too. So the next one is new modulation coding and waveform. If you take a look at this right-hand side, we all know that from 4G and 5G, we have been utilizing OFDM and also kind of different orders of QAM modulation schemes. So this slide shows 1024 or 1K QAM constellation. And as shown at the left-hand side, we have been utilizing this rectangular type or regular constellation. But also at the same time, we know that this is not really perfect or optimal. So I think we have an opportunity to redesign this QAM constellation. And if you take a look at right-hand side, we kind of developed some new constellation scheme utilizing AI technology. And our initial results show that basically using this kind of irregular AI-based new constellation, we can save energy because to achieve the same error performance, we can reduce the output power. The last item in sustainable network is about scalable VRAN. I believe many of you heard that today, RAN is not, let me put it this way. RAN technology or base station equipment has been very special purpose hardware traditionally, right? But today, there's a big trend that this RAN equipment is running on COTS server and then basically running in terms of software. And we call it VRAN, virtualized RAN. And VRAN is kind of being deployed in different places, and I'm proud to say that Samsung has been leading this technology in the industry today. We are making this VRAN in a kind of, so that it can be scalable. What I'm trying to say that is, if you take a look at the left-hand side, basically there is a single cell, and there's a server, and then there is one containerized pod. And then as we add more cells, basically we need more computing power, right? And then we scale up this VRAN pod so that more capability can be added into server. Of course, along with that, we can add more servers too. But anyway, what I'm trying to say is in basically containerized cloud-native environment, basically these pods can be scaled out, scaled in, depending on the computation needs and so on, right? So today, VRANs are not that much scalable, but we have been working on that, and we are making some good progress. This kind of approach can be very useful if we have to handle time-varying traffic amount of traffic load. So if you take a look at the right-hand side, the traffic load varies over time, right? Apparently, for a day, overnight, basically very small amount of traffic, but during daytime, a lot of traffic, right? So that means the computational power which we need to take care of this traffic will vary over time. So what's shown in here is, well, during nighttime, only single pod is used. And then over daytime, basically, we scale out this pod so that 3 pods work together to take care of this high traffic load, and so on. Then, if there is a single pod operation, basically the remaining computing resources can be saved, and then that can be that can result in less energy consumption too. So anyway, this kind of scalability support in cloud-native environment has been kind of norm in IT system. However, it hasn't been like that in our mobile communication. But along with the introduction of this virtualized RAN technology, I believe that we have an opportunity to make our 6G system like a big, giant IT system, right? And then we are working towards that direction today. So the third one is ubiquitous coverage. So I will briefly talk about what we are trying to do in different frequency ranges. So earlier I mentioned FR1 under 7 gigahertz, FR2 in millimeter wave range, and FR3 upper midband, and so on. So FR1 and 2 are the spectrum range, frequency range we are using already today, right? But what I'm trying to say is we need to improve the performance in this spectrum or frequency range in different manners. So especially in FR1, basically we are currently utilizing MIMO technology heavily. And also especially in C-band, we are using massive MIMO and so on, right? But as shown in this slide, especially in sub 3.5 gigahertz, we have less opportunity to use a lot of antenna, given that the wavelength is large, so that antenna elements, the distance will be large, so that given the limited size of antenna panel, we cannot put a lot of antenna elements. Then the new opportunity in this area is if we can utilize multiple antenna panels which are geographically distributed, then even if we handle kind of this low frequency range, we have an opportunity to support massive MIMO technology in this low spectrum. So we call it distributed MIMO, right? So by distributing multiple antenna panels in a distributed manner geographically, then even if we take care of this low spectrum, we can utilize a lot of antenna elements so that we can improve the performance in different manners in terms of coverage and also energy efficiency, capacity, and coverage whole, and so on. The key in there is we need to take care of the scheduling in a centralized manner. So I think we need to work on that. The next one is right-hand side in millimeter wave. So actually, millimeter wave had a lot of promise. Today, I think there was a lot of disappointment too. But I believe we have to continue to work on that. Especially, as you might know, FR2 millimeter wave has been utilizing hybrid beamforming, but mostly analog beamforming. So the disadvantage or limitation of analog beamforming is at a single time, you can make only a single beam. So basically, multi-user MIMO kind of things is very difficult to achieve. But by utilizing a new technology called JPTA, which means joint phase and time array, basically we can make multiple beams in a single time slot so that multiple users can receive or transmit signal at the same time. Well, actually, if you can imagine what will happen then, there can be a lot of advantages, and one of them is, again, coverage extension for uplink transmission. You might have heard a technology called XDD, cross-division duplex. or it is called, I think, sub-band full duplex within 3GPP, working group. This kind of technology has also uplink coverage extension. We are trying to achieve similar thing with JPTA2. Yeah, the next one is FR3, or upper midband. So upper midband, again, the frequency range is 7 to 24. But as you might know, actually many countries, including the US and Korea, are considering identifying some new spectrum in this range. And one of them is, for example, 13 gigahertz, 12.7 to 13.25 gigahertz. And then if you think about the difference between 13 gigahertz and 2.5 gigahertz, roughly that's 4 times, right? So if we fix the antenna panel size, we can put 16 times more antenna elements. So the left-hand side, we see that in basically 3.5 gigahertz, we have 129 antenna elements. But if you kind of scale up this dimension and so on, in 13 gigahertz, we have over 3K, or 3,000 antenna elements. At the same time, we can increase the digital port number from 64 to 256 digital ports. Then, basically, we can try to provide this extremely massive MIMO. So we actually call X-MIMO. And using this X-MIMO, the coverage of this 13 gigahertz can be similar to C-band, or 3.5 gigahertz, because the antenna panel size remains the same. At the same time, because we have 4 times more digital ports, we can increase multi-user gain more so that overall capacity can be increased. The last one is about multi-connectivity network, including satellite. So actually, satellite to phone direct communication is happening already. And as part of 5G Advanced, actually 3GPP is defining this phone to satellite communication in a more advanced manner. And given that that's happening, and hopefully assuming that more satellites in the coming years will support this kind of future-proof 5G Advanced and possibly 6G, I believe 6G will have global communication support across South Pole to North Pole and so on. So this is the last slide. Last but not least, I think we have to take a look at the security, privacy, high resiliency, and so on. So the first one is quantum safeness. Basically, I think a lot of people are working on quantum computers today, and we know that once quantum computers are introduced, today's security system might not be safe anymore. So people are developing post-quantum cryptography today. And based on our initial evaluation, this PQC can be used even today without much computational overhead. And so given that, we believe that 6G should be defined by incorporating this PQC as part of 6G, so that 6G will be the most secure mobile communication ever. Well, along that line, actually, zero trust architecture is another important, I think, component today too, I believe. So within zero trust architecture, all the network entities do not trust each other and try to monitor itself and authenticate each other and so on, so that basically all the network entities can trust and then provide very secure communication to end user. Again, the next one is high resiliency. So earlier I mentioned vRAN and also cloud vRAN, scalable vRAN, and it should be defined in a manner that it is very reliable. For that, I think we need to have some better load balancing technology and so on. So as I said already, given that 6G will be like big IT system today, I think it will provide scalability and also high resilience and so on. And towards 6G direction, I think we need to continue to work on that. So that's it for today. I was very happy to share our ideas about 6G. And as I keep saying, basically 6G is a really big thing, right? And also we are working on it with very long-term vision, right? And it's not something like we can do alone. We have to collaborate across all the stakeholders, including government, industry, academia, and so on. And I believe this kind of event, 6G Global, is a good place for us to communicate each other and plan for collaboration in the coming years. So that's it for today. Please enjoy the rest of this event. Thank you very much.